start our next set of notes, which is covalent bonds. So quick recap. Our ionic bond was between a metal and a nonmetal, right? With between a positive ion and a negative ion, opposite sides of the periodic table. So now what are covalent bonds? So covalent bonds are between a nonmetal and a nonmetal. And what color do I feel like going today here? Let's match with this blue. So ionic, right? So I'm just going to throw that up here at the top, right? So ionic is between a metal and a nonmetal, opposite charges of the table. So now we have covalent. What does our prefix co mean? I love to pick apart words. Co means share or together. So covalent, and that's part of the word valence. So it looks like we might be doing some kind of cooperating or sharing of those valence electrons. And it's not between a metal and a nonmetal. And in this case, it's between a nonmetal and a nonmetal, which means two things to the right of the staircase. So on the right side of your periodic table. So everything on your right-hand side of the periodic table over here, so let me just move that over here, already has almost 8, right? So starting with carbon and going over, we have starting with 4. So 5, 6, 7, 8. So in this case, they're going to want to gain electrons to get that stable electron configuration. They're not going to want to try to lose any. So no one's going to want to try to lose 6, for example. We want to try to gain those electrons. But then if you got a bunch of elements that all want to gain, how do they get to that 8 if nobody's willing to lose? They can work together and they can share those electrons. And that is going to be a covalent bond. So it's considered an orbital lap. And remember, orbitals is the most probable location of the electron, right? So chemistry builds between two atoms. So then this is a sharing of electrons. One of the ways that I like to remember between the difference between ionic and covalent is TICS. And what does that stand for? That stands for transfer, ionic, and covalent, share. Right? And barf, break and absorbs energy and release when energy when bonds are formed. So some little memory devices help you. Now, what is a molecule? So a molecule is a group of non-metal atoms that are held together by covalent bonds. We use the word compound when we are referring to ionic substances. We use the word molecule when we talk about covalently bonded substances, right? So water, for example, we say it's a molecule of water because we have oxygen, which is a nonmetal, and we have hydrogen, which is another nonmetal. So we have two nonmetals, covalent bond. So now we call those molecular compounds. So when you see the word molecular, this means a covalent bond, okay? Because covalent bonds make molecules. All right, so they have a low melting point. Now, ionic and covalent are opposite. Transfer, share. Metal and nonmetal, just nonmetals. So now these are the opposite characteristics of ionic compounds. So in chemistry, you don't have to memorize things twice, because if you know it in one direction, the opposite is completely reversed. Ionic compounds have a high melting point, so molecular or covalently bonded compounds have a low melting point, molecules. Right? So it also means low boiling point. And we have gas, liquid, or soft solids, right? Butter or wax at room temperature. So like my candles in the classroom. And we have nonmetal and nonmetal combination, right? Everything to the right of the staircase with the exception of hydrogen, because hydrogen is a nonmetal, even though it's over on the left-hand side of the periodic table. And these do not conduct heat and electricity. These are considered insulators, so they do not conduct electricity. So how many covalent bonds can an atom form? as many bonds as there are single or unpaired electrons. So let's take a look. So we have the element oxygen, we have the element nitrogen, and we have our element fluorine. And let's talk about hydrogen. Let me go backwards. So if we're looking at our periodic table, so oxygen, let's take a look at, I'm going to draw the electron dot. Oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6. How many open spots? 2. So that means oxygen has to form 2 bonds. Now let's take a look at nitrogen. Nitrogen has 5 valence electrons. 1, 2, 3, 4, 5. How many open spots? Unpaired electrons. There's going to be 3. So nitrogen needs to form 3 bonds to have a stable electron configuration. Fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, and 7. Has 1 open spot. That means it has 1 unpaired electron, and it needs to form 1 bond to have a stable electron configuration. Hydrogen has 1 valence electron. Oops, let me do that. And again, the reason with the whole dots thing with my tablet here. So it has only 1 unpaired electron. I know you might think that it has some extras over here. It doesn't. Remember, helium, the first energy level that helium has, and helium is a noble gas and is considered stable with 2 electrons. It has 1 paired electron and it needs to form 1 bond. What I'd like you to do is let's take a look at our periodic table and let's look at position. I like to think of my periodic table as like the best game board there ever was. So let's look at oxygen, for example. So oxygen is right here on our periodic table. Oxygen has 6 valence electrons. It needs 2 more to have 8. So that means it's going to be 2 hops away from neon. So that means it has to form 2 bonds. Let's look at nitrogen's position. Nitrogen's position is here. It has 5 valence electrons. It needs 3 more to get 8. So it has to form 3 bonds. How many hops away from a noble gas? 3. 1, 2, 3. And so now let's look at fluorine. Fluorine is 1 hop away from a noble gas. It forms 1 bond because it has 7. It has needs only 1 more electron. Now let's look over here at hydrogen. Hydrogen is 1 hop, I know it's a big one, over here to helium. So it's going to form 1 bond. So let's talk about one that we didn't look at. We're going to talk a lot about this when we do our organic unit coming up. Carbon is here. How many bonds? So it has 4 valence electrons. So how many bonds does carbon need to make? If you're guessing 4, your answer is right, because it's 1, 2, 3, 4. It needs to gain 4 electrons to get a stable electron configuration. And now we're going to have a new way to draw electron diagrams for molecular compounds. And remember, molecular means covalent. And I'm just going to write this over here. Ionic, right? We use the brackets. And you have your metal that's positive, and you have your non-metal that is negative. No dots for the metal, and then 8 dots for whatever your non-metal is, and whatever the charge for the periodic table, because ionic is between a metal and a non-metal. So molecular is covalent. So the prefix co means share. Look at ionic, right? I remember how I said that these look like backwards brackets, and the capital letter I is like very straight lines and very rigid structure. Well, covalent is like a C is nice and curvy, and an O is nice and O. So I'm going to think in terms of molecular compounds, dot diagrams. We're going to be using some circles, because these are going to show a sharing of electrons. They need to share electrons to get to the noble gas configuration, and we share by circling them together. Oops, I have the hiccups. Oops. Okay, so let's look at a hydrogen molecule. What is hydrogen? Hydrogen is H2. So now hydrogen has 1 valence electron. I'm just going to draw it to the side just to make it easier, and of course. and I've got the other hydrogen, and they each have one valence electron. So together, remember, so hydrogen is one hop away, has one unpaired electron, it has to form one bond. So I'm going to circle those two electrons, and there's our bond. And then that can become, now we can show that those two electrons as a line. So hydrogen, hydrogen. So this line right here represents a shared pair of two electrons, right? So two electrons, one pair, or two total electrons. So now let's look at hydrogen chloride, right? We have H and a Cl. Hydrogen has one valence electron, and chlorine has 7 valence electrons. 2, 1, 2, 3, 4, 5, 6, and 7. Chlorine has one open spot. It needs to form one bond. Hydrogen also has to form one bond. So together they can share those electrons to form a bond. And so then I can redraw this. Hydrogen, now my shared pair of electrons, right? The line showing a bond. And now here's my chlorine. And I can't forget those extra electrons that chlorine has. That's very important. Chlorine has those. It wants to show those off. All right, so that's hydrogen chloride. So now let's do ammonia, which is NH3. So let's look at our periodic table because we need to know our valence electrons. Nitrogen has 5. Each of these hydrogens has 1. So let's start with the nitrogen as our center atom here. So 1, 2, 3, 4, and 5. So nitrogen has 3 spots to fill. It's got 3 hops away from a noble gas. So it means it's going to form 3 bonds. So it has 3 bonds, and I have 3 hydrogens to make those bonds with. So I'll do a hydrogen here with its 1 valence electron, and there's 1 bond formed. Now I'll do my second hydrogen. I'll do that right here. And there's my second bond formed. And there's my third hydrogen, and there's my third bond formed. And so remember, now our circles then become lines. So our nitrogen with our 2 valence electrons, and now here's 1 bond, there's 2 bonds, and then there's 3 bonds. I still need those 2 dots over nitrogen because nitrogen has those electrons and it wants to show them off. It's like a little bit of bling for those elements. Remember, every line, right? So every single one of those lines is 1 pair of electrons or 2 electrons. So now let's look at oxygen, right? Don't forget, you need to know your diatomics, Brinkelhoff, Hoff-Brinkel, right? You're 7 up on your periodic table, you need to know those. So oxygen is O2. So now oxygen and nitrogen are a little bit tricky. So now let's making sure that we're looking at our periodic table. Oxygen has 6 valence electrons. So then I'm going to draw an oxygen. I've got 2 oxygens, and they each have 6 valence electrons. 1, 2, 3, 4, 5, 6. And since I like to circle things between, that's why I put that one over here instead of over here. So now 1, 2, 3, 4, 5, and 6. So those have 6 valence electrons. And so a bond forms when we share 2 electrons. So it looks like these 2 can share right there. So there's 1 bond. And it looks like these 2 can share as well, because oxygen has to form 2 bonds. Oxygen is 2 hops away from the noble gas. It has to form 2 bonds. Did I make 2 bonds? Yes. So now my circles then become lines. So I have an oxygen, and now I formed 2 bonds between those oxygens. So this is called a double bond. So I'll just write that over here. This is a double bond. And now don't forget, oxygen wants to show off all those extra electrons it has. So there's still 4 electrons over there, and this one also has 4 electrons over there. So this is called a double bond. So then this is going to be 2 pairs of electrons that are shared, or 4 total, because every line is 2 electrons. So now let's look at nitrogen. Looking at the periodic table, nitrogen is 3 hops away from a noble gas. It has 3 open spaces, 3 unpaired electrons. I should be making 3 bonds. So let's see how this goes. So then I have nitrogen, which is N2, because right, it's a diatomic. And so I'm going to do 2 nitrogens. Nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. And now I'm going to do my next nitrogen. 1, 2, 3, 4, 5. And so now I'm going to circle my unpaired electrons. So here's a pair right there. So there's 1 bond. Remember, I need to form 3 bonds. And so here's another pair, right? It has to be shared between 2, right? I can't share within the same element, right? I have to share between the 2. So now I've got 1 over here and I got 1 over there. Can I share those? Yes. It might look weird to you because remember, this is a 2-dimensional drawing of what exists in 3-dimensional. These are orbitals that overlap, right? We have all this electron clouds and those clouds then overlap each other. So then yes, you can still share those electrons. So I'm just going to give that a circle right there. So I'm just going to circle those like that. So now I have those 3 circles. So I have my 2 nitrogens and I have formed 3 bonds. That's called a triple bond. Don't forget, each of those nitrogens has 2 electrons. So I'm going to make sure I'm going to put those here and I'm going to put those there. Why didn't I not put them on top? Because remember, negative charges repel. This whole cluster in the center is 3 pairs of electrons, or 6 total electrons. And those are negatively charged particles. And these electrons over here on the outside, these are also negatively charged particles. So they're actually going to go out to the outside. If you stuck them on top of the nitrogen, you'd probably still get points. It's just, let's finesse it by spreading out the pairs so that they're as far away from each other as possible. So keep in mind when you're writing these Lewis electron dot formulas, you're looking at position on the periodic table, you're checking to see how many unpaired electrons there are, so you know how many bonds that you should be making. And that is going to wrap up our covalent bonds, right, our molecular compounds. And these are called Lewis electron dots. So what you should be able to do is you should be, sorry, I need to go backwards. You need to practice writing these because these are very popular short answer questions on the Regents exam. You have to be able to draw all of the diatomics. And you have to be able to draw ammonia and oxygen and nitrogen, right? Those are still part of the diatomics. But now let's do one more because I don't know, I just feel like doing one more. Let's do water, which is H2O, because that's another one that you're very likely going to have to draw. So oxygen has 6 valence electrons, 1, 2, 3, 4, 5, and 6. Hydrogen has 1 valence electron. Oxygen has to make 2 bonds. Hydrogen has to make 1. So I'm going to put 1 hydrogen here with its 1 dot, and my other hydrogen here with its 1 dot. And so now we form a bond here, and we form a bond here. And so when these get together, I have my oxygen, and I have this hydrogen here, and then I have this hydrogen over here. And then don't forget, oxygen's got that extra bling, those extra electrons, and now there is your water molecule. I just do want to point out, I'm going to switch my color to red, so to show you something that you should not do. So notice how I have this bent molecule. This is not water. You cannot do this. So I'm going to do like a red no. Okay? Because when we did these dots and we go one at a time, it left our open spots here, right? It left our open spots here and here, not on either side. Okay? So then that's why we are going to end up with this. And it makes more sense in our next set of notes when we talk about polarity and we extend our thinking, right? Until our next set of notes. Practice these Lewis dot diagrams, draw them over and over and over again so that you can do them in your sleep. All right, until next time. Good job.